Under the special operations, specifically keeping in mind the use of some navigational equipment, we will today discuss about Traffic Collision Avoidance System or TCAS. The content of this presentation was created by these two interns, Soumya in 2020 and updated recently by Yash Kapshikar. What is TCAS? It goes by another name called as ACAS or Airborne Collision Avoidance System. Well, the name itself tells you what it is. It is to avoid collision between two or more airborne systems, mainly between two airborne systems. So that is what the whole purpose is. It is there to reduce mid-air collisions. This is the last resort safety net available to the aircraft, irrespective of any separation standards, and TCAS is the only system whose instructions have to be used by the pilots, even overriding the command given by the ATC. This is the only place where the pilot may not follow the commands of the ATC. If there is a conflict between the command given by the TCAS or ACAS and the ATC, today the rule says that you have to give more importance to the command from the TCAS. So this is a very unique situation where the pilot may disobey the instructions of the air traffic controller, and hence it is a system that is independent of the ATC. What does TCAS system do? It monitors the airspace around the aircraft equipped with an active transponder, and importantly it issues advisories, that is traffic advisories or TAs, or traffic warnings, which are concerned with the air traffic nearby. TCAS or ACAS are used interchangeably in many cases. They are based on the secondary surveillance radar or SSR transponder signals, which means TCAS signals will be released or work only when the transponder is working. Now, the alerts given by TCAS 2, now there are TCAS also has got different versions, there is TCAS 1 and TCAS 2, we will see very soon. In two alerts that can be issued by TCAS 2, which is the advanced version of TCAS, are the traffic advisory or TA and the resolution advisory or the RA. Obviously, RA is much more important than TA. TA tells you only about the traffic which is present and it is a warning, but RA is actually an instruction that please do this, climb, 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 or descend, 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 that kind of instruction. So the TA or the traffic advisory alerts, the TA alerts are assisting the pilots in the visual acquisition of the conflicting aircraft. So on the screen, as I will show you very soon, you will see where the pilot gets an information. So it prepares the pilot for a potential resource advisory. If the conflict continues to grow, then there will be an RA. So if the risk of collision is established by the TCAS 2 system, then the next step, as I mentioned, the more important step is a resolution advisory or RA. Now basically in RA, the pilot is told the range of the vertical speed at which the aircraft should be flown to avoid the imminent threat aircraft. So as I said, there are two types of TCAS 1 and 2. TCAS 1 is meant for small aircraft with around 10 to 30 passengers. TCAS 2 is for larger aircraft, more than 30 passengers. TCAS 1 provides only the traffic advisory, it does not have the resolution advisory, but TCAS 2 gives you both traffic advisory and resolution advisory. TCAS 1 is recommended for the general aviation aircraft, small aircraft which are used for not for commercial purposes, and helicopters, whereas TCAS-2 is not mandated for GAs, it is generally meant for large commercial aircraft. Now, there is a protected volume, and that is a function, the size of that is a function of many things: altitude, for example, at which you are flying, at what speed you are flying, and what is the heading of the aircraft which is in a probable conflict. And then you have to do some avoidance maneuvers. So, you can see, for example, the pink region is the resolution advisory region of TCAS, which is about 600 feet plus minus and about 25 seconds of flying or 2.1 nautical miles distance. Then there is a TA region or the traffic advisory, which is marked in yellow colors, that is 850 feet on both sides of the center line, and the distance is going to be around 3.3 nautical miles or about 40 seconds. Okay. So, this is basically the size of the protected volume. So, what is the avoidance maneuver? One is change in the altitude. So, the TCAS system will talk to the TCAS of the other aircraft, and then they will give jointly an advisory for one aircraft to climb and the other to descend. Or you could modify your climb or sink rate. If you are in the climbing position or sinking position, you can ask you to modify. Okay. So, here are these two aircraft. So, this aircraft is querying the other one, and it says, I am at 5000 feet, what is your altitude? The other fellow says, oh, I am also at the same altitude. So, then immediately there is a warning issued, and then the aircraft are made to go in a different direction if possible. Generally, it is altitude change. So, the collision area is shown, there is a warning area and there is a caution area. The warning area is where the RA or the resolution advisories are given. This gives the pilot around 15 to 30 seconds to react, but there is a traffic advisory section which gives you 20 to 48 seconds to react to the intruder aircraft. And the same thing is shown in the side view. Okay. The components in the TCAS-2 which help us arrive at these warnings are shown in this particular sketch. The computer unit or the TCAS computer is the most important aspect, which is used to carry out surveillance of the aircraft in the neighborhood, track any intruder, track the altitude of self and the intruder, detect whether there is a threat, and then give a decision regarding RA, and it also determines the volume to be protected. It also controls the logical parameters for collision avoidance. This is the job done by the TCAS computer. Then you have an antenna, which you have on the top an antenna for directional advisory, and on the bottom you have an omni antenna. Okay. These two antennas are used for the mode S transponder. Then you have a presentation of the information in the cockpit. So, that is done using the TA display. So, you can see here, this is the display that the pilot gets. This is where your aircraft is. This is non-threat traffic because they are nearby, but they are moving in some other direction. They are probably moving in this direction. So, there is no chance of any threat. Similarly, this is another one which is moving, maybe moving that way or that way. This one is a traffic advisory. It tells you that at the same altitude, there is an aircraft which is probably moving in your direction. If this aircraft was moving in the other direction, this signal would have been not yellow circle but a blue. Okay. Now, if there is a rhombus, that means unfilled rhombus, then the traffic is below, and this is the filled one shows you traffic in the close proximity, right, and this one is dangerous. This is telling you that there is an aircraft which is 7,000 feet above you and it is descending. The arrow down shows descending. So, this aircraft is 7,000 feet above you, it is approaching towards you and it is descending. So, it could be a potential danger. So, this is called as a resolution advisory. Okay. Then we also have the display of resolution advisory on the cockpit. Okay. So, you will have the VSI operating normally, that means there will be 0 vertical speed. This is the TCAS RA display providing climb guidance. Okay. It is telling you that do not go into this area, go into this area, and aircraft climbing at required rate. So, it will tell you that you are in the green area. So, you are at the right place. This is the normal condition, this is the advisory, and this is the feedback to the pilot if the advisory has been properly implemented by the pilot. Now, there is a transponder. So, what is a transponder? When the aircraft radar hits an aircraft, another aircraft, the radar electronically queries who are you. The transponder replies with a 4-digit code and altitude that is seen on the display. This transponder data is also used by other systems who are tracking the aircraft. Okay. So, this is here. Now, let us look at the display warning on the TCAS. So, there are various symbols. So, as I showed you, your own aircraft is shown in an aircraft like symbol or a white or cyan. Other traffic is unfilled diamond, which altitude is not known or it is very far away. Proximate traffic is shown with the altitude, that is how many 100 feet above or below, and also whether it is coming down or going up. This is the traffic advisory which tells you that there is an aircraft which is 900 feet below and level. So, it is a potential conflict, and this one is the most serious one. The resolution advisory which tells you that there is a dangerous aircraft 500 feet below -0.5 and climbing, that is called as a filled red square. You can see all these kinds of symbols are shown here. Okay. What does the TCAS do actually? It surveys the airspace around your aircraft. It seeks replies from the intruder aircraft transponder. It tracks and prioritizes these replies because there could be many aircraft which are responding. Some are far away, some are nearby approaching, some are nearby but deviating, some of them are very near and maybe intruding. So, it tracks all of these and then it prioritizes the replies. Then it predicts the path of all these aircraft which are relative to your aircraft, and if it detects there is a possibility of a conflict, then it enunciates those predicted to penetrate your collision airspace. So, the TCAS system is only concerned about the possibility of neighboring aircraft coming into the proximity of your aircraft and becoming a potential threat. So, that is why it monitors all the aircraft in its neighborhood. Now, in the Indian airspace, we need to be sensitive to the fact that we had a very sad incident, a mid-air collision in 1996, which is called as the Charkhi Dadri mid-air collision. In this particular collision, there were 2 aircraft involved, a Saudi Arabian Airlines Boeing 747-100B travelling from Delhi to Dhahran, it was climbing, and there was a Kazakhstan Airlines IL-76 cargo aircraft which was travelling from Chimkent in Kazakhstan to Delhi. This was in the descending path. Now, because of the confusion and wrong setting of the instrument altimeter reference point, both of them actually were at the same altitude, and when they communicated with the ATCO, they both communicated that they are at the right altitude and there was a mid-air collision. This collision was very deadly. It actually killed all the 349 passengers on board both the aircraft. There were more people, of course, there were few people, 6 or 7 people only in the Kazakhstan cargo aircraft, mainly the crew members, but majority of the people were present in the Saudi Arabian Airlines going to Dhahran. All of them were killed. Now, the investigation was launched, and then in April 1997, the investigation was concluded and the reason was identified. There were many reasons which were identified. One reason was that at that time the approach and the departure routes of the aircraft at Delhi airport were same. So, as a consequence of that, there was a chance. So now they have changed the routing so that the route taken by the aircraft when they approach Delhi is different from the route when they depart from Delhi. And secondly, there was no secondary surveillance radar which actually gives the altitude of the aircraft proactively to the pilots. Till that time, the radar was only able to locate the aircraft laterally, and the altitude information was communicated by the pilot. Now, if the pilot has a confusion or if the instruments have a malfunction, the information communicated to the ATC will be wrong, and that is what happened in this case. So, as a result of this, a very bold decision was taken by our DGCA, a very bold decision that within a very short time, all aircraft entering the Indian airspace, TCAS 2 was made mandatory, and this was on 1st January 1999. There was a huge hue and cry because installation of TCAS system is a very expensive thing, and many airlines were objecting, but we stood to our ground and we said no for the requirement of TCAS 2 being made mandatory in Indian airspace will ensure that such things never occur in the future. Now, there were some concessions given for new aircraft, right, which had more than 30 passengers or more than 3 tons cargo. The new aircraft which were to be fitted was given some more time, 1st Jan 2002, but any aircraft operating existing aircraft had to be installed 1st January 1999. The existing aircraft also with 30 seats or max takeoff weight 5700, they were allowed to refit it from 1st Jan 2005, and smaller aircraft which are having 10 or 19 seats, they were allowed to use ACAS 1 or TCAS 1 rather than TCAS 2. So, they will only get the traffic advisories and not the resolution advisories, but that is deemed to be sufficient for small aircraft. So, this is how the TCAS system became compulsory for operation within the Indian airspace. Thank you for your attention.